How's it going, guys? Today we're going to be going over Module 5.4, solving system of linear inequalities with real-world problems, real-world applications. So we're going to jump right into an example. For example 1, we're told Sandy makes a $2 profit on every cup of juice that she sells and $1 on every fruit bar that she sells. She wants to sell at least 5 fruit bars per day and at least 5 cups of juice per day. She wants to earn at least $25 per day, and we're going to show and describe all the possible combinations of juice and fruit bars that Sandy needs to sell to meet her goals. And then we're going to pick 2 possible combinations that meet her goal. So first thing we're going to do is we're going to define our variables. In this problem, our variables are going to be cups of juice, the amount of cups of juice that she sells, and y is going to be the number of fruit bars that she sells. Okay, so x is the number of cups of juice that she sells, and y is the number of fruit bars that she sells. After that, we're going to go ahead and make our inequalities. So we're going to go back to the word problem, look at it, see what it tells us, and we're going to make our own inequalities. So for for the first inequality, we're told that Sandy makes a $2 profit on every cup of juice that she sells and $1 on every fruit bar that she sells. That doesn't really tell us too much, but in the next sentence, it does tell us that she wants to sell at least 5 fruit bars per day. So that tells me my y needs to be greater than or equal to 5. That's because the number of fruit bars that she wants to sell has to be greater than 5. After that, we're told that she wants to also sell at least 5 cups of juice per day. So that tells me x needs to be greater than or equal to 5. And the last thing we're told is that she wants to earn at least $25 per day. So her total profit needs to be at least $25. And we go back to the first sentence of the problem. It tells us she makes $2 profit on every cup of juice that she sells and $1 profit on every fruit bar that she sells. So we know our equation for the profit is going to be 2x, $2 profit per the amount of cups of juice that she sells, plus 1y, or $1 profit per fruit bar that she sells, and that needs to be greater than or equal to 25. We have our 3 inequalities. We're going to go ahead and graph them. Let's label our graph first. I'm going to go up by 5s. 25 and 30. There we go. So first thing I'm going to go is I'm going to graph my y is greater than or equal to 5. So when y is greater than or equal to 5, we know we have a horizontal line because we're going to be graphing it as y equals 5. And we want everything above it. So everything up here is a solution for y is greater than or equal to 5. And it'll be a solid line since we're told it's also equal to 5. After that, we're going to graph x is greater than or equal to 5. We're going to graph that as x equals 5 first, and then we'll shade in the appropriate side. So x equals 5. It's going to be solid since it's also equal to 5. And we're going to graph everything everything to the right side of x, since we want all the x values bigger than 5. So everything over here is what we're going to shade in for x is greater than or equal to 5. And lastly, we're going to graph 2x plus 1y is greater than or equal to 25. But before we do that, we need to solve for y equals, or isolate the y, in other words. So we have 2x plus y has to be greater than or equal to 25. I'm going to move the 2x to the other side, so y is greater than or equal to negative 2x plus 25. And I'm going to graph this inequality as y equals negative 2x plus 25 first, and then I'll change it, or then I'll shade the appropriate side for the inequality. So when I'm trying to graph y is equal to negative 2x plus 25, I can tell my y-intercept will be 25 since that's my p-value. So I'm going to go ahead and put my point over there. And after that, what I'm going to do is I'm actually going to solve for my x-intercept. I think graphing will be a little easier than going down 2 and write 1 all the way down. So to solve for your x-intercept, you just set y equal to 0. So I'm going to do this over here. So y equals 0, we plug it in. So we have 0 equals negative 2x plus 25. We're going to add 2x over. So 2x equals 25. And x equals 12.5. So when y is 0, x equals 12.5. Or in other words, our x-intercept is at 12.5. So I think it's going to be just about over here. And now all I need to do is draw a line from one point to the other. So over here, down to here. That's my line. Let me retrace it in blue. Or not. Let's go back to my pen. There we go. So that's going to be my line. And we want everything greater than or equal to that line. So in other words, we want everything above that line. So everything up here is going to be a solution to y is greater than or equal to negative 2x plus 25. After that, we were finished. We did all 3 of our inequalities. Now it's time to look at the graph, look at this drawing that we did, and see where all 3 colors overlap. And we see they all overlap in this part right here. I'm tracing in black. Went a little below the red line, wasn't supposed to. There we go. Everything in here in the black shaded region is a solution to my system of inequalities. So we need to pick 2 solutions. We can do 1510. And we can also do 1616. It doesn't really matter. There's an infinite amount of solutions. It just needs to be in that solution set. So let's go on to number 2. For number 2, we're told Vance wants to fence in a rectangular area for his dog. He wants the length of the rectangle to be at least 30 feet and the perimeter to be no more than 150 feet. We're going to graph all possible dimensions of the rectangle. So first thing, we're going to define our variables. X equals length. And y is going to be width. All right, so x is our length, y is our width, and now we're going to figure out what our inequalities are going to be. So we're going to go back to the problem, see what it tells us. The very first thing it tells us is that we want the length of the rectangle. He wants the length of the rectangle to be at least 30 feet. So you want he wants an x to be greater than or equal to 30. After that, we're told he also wants the perimeter to be no more than 150 feet. So the equation for a perimeter is 2L plus 2W. So in this case, it will be 2x plus 2y has to be less than or equal to 150 because he wants to be no more than 150 feet. So it can be 150 feet, but it can't be any more than that. After that, we do have one more inequality to put down. It's not really the problem, but we need to make sure our y stays above 0. We can't have a negative width. It doesn't make sense. So let's make sure our y also stays above 0. So let's go ahead and graph our inequalities. So for the first, or before we do that, actually, let's label our graph. This graph's a little small. I went up by 25 to make it fit. So 25, 50, 75, 100, 125, and 150. And for the y's, also up by 25. Completely skip 75 there. And 100. There we go. After that, then we're going to graph our inequalities. We start with x is greater than or equal to 30. So x is greater than or equal to 30. It's going to be right about here. And it's going to be a solid line since we want everything greater than 30. So if we want all the x values greater than 30, we're going to shape everything to the right, or this part over here. After that, we want 2x plus 2y is going to be less than or equal to 150. Let's do that in green. So let's go ahead and create our equation for that. We have 2x plus 2y is less than or equal to 150. We're going to isolate our y. So we have 2y is less than or equal to negative 2x plus 150. Then we'll divide everything by 2. So we get y is less than or equal to negative x plus 75. And we're going to graph this as y equals negative x plus 75. We're just graphing it like that, and we'll deal with the inequality after we graph it. So I'm going to graph this the same way I did the last slide. I'm going to use my x and y intercepts. I think it'll be a little easier, especially with big numbers like this. So I know my my y-intercept is going to be 75, and that's because our b value is 75. After that, I'm going to solve for my x value, my x-intercept. And our x-intercept happens when y is equal to 0. So I'm going to plug 0 into my equation. So 0 equals negative x plus 75. And then I'll add x over. So I have x equals 75. So on the x, so when y equals 0, x equals 75. So that tells me I have another point at 75, 0. So same thing, we're going to draw a line right there, from here to this point. And again, I'm going to retrace it in green, because that's the color I chose for this line, or for this inequality. Okay, after that, we want everything less than or equal to this line, so I'm going to shade everything underneath it. And that is where the solution for that inequality is. After that, we have one more. That's just the y is greater than 0. This is going to be dashed. So just we need to make sure we stay above this line. Because anything below it is saying y has a negative value. That doesn't make any sense. So our solution set will be inside of this triangle here, not including the x-axis. Since that says y is 0, you can't have a width of 0. That just gives you a line. So our solution set is right here in this triangle. Okay. So we're going to go ahead and pick 2 solutions for this as well. We see we have 50, 25. And I guess we can do 62. That works too. Okay. For number 3 and 4, how about you guys try it yourselves? Pause for a second, pause the video, and then I'll show the answer afterwards. Okay. So this is the answer to number 3. I made my x be equal to the number of gallons of red paint that Olivia has, and my y to be the number of gallons of blue paint that she has. The inequalities I got were 20x plus 30y has to be less than or equal to 270, since she can't spend more than $270. That's her limit. And 500x plus 500y has to be greater than or equal to 5,000. That's because 500x tells me how many square feet I can paint with all the red paint that I have. And 500y tells me all the square feet I can paint with all my blue paint. Add them together, that's how much paint I can paint, or how many square feet I can paint with all the paint that I have. And that has to be greater than or equal to 5,000. And that's because I need to paint at least 5,000 square feet on the billboard. If I have extra paint, it's not a big deal. We just need to make sure we can at least fill the billboard. If you chose different x and different y's, your graph will look a little different than mine. As long as your inequalities are okay and you graphed it right, it's okay. The only difference is my x-axis will be your y-axis and my y-axis will be your x-axis. So it's gonna be flipped that way. If you chose your gallons of blue paint to be your x and your gallons of red paint to be your y. So same thing. After this, you guys can pause the video and I'll show up the answer to number 4 after that. Okay, This is the solution to number 4. So we defined our variables. I made X be bagels and Y be muffins. Same thing. If you flip flop them, it's not a big deal. Your graph is just going to be a little different. Your inequalities should be very similar. So inequalities that I got were 10y plus 15x has to be less than or equal to 60, and that's because he has a limit of $60 to spend, and it costs $10 to make a dozen of muffins, and it costs $15 to make a dozen of bagels. So 10y plus 15x has to be less than or equal to 60. He can't spend more than he has. And y plus 2x, I got to be less than or equal to 8, since it takes 1 hour to make a dozen of muffins and 2 hours to make a dozen of bagels. And he only has 8 hours to make all the muffins and bagels, so he can't spend more time than he has. So y plus 2x has to be less than or equal to 8. I went up by 3s on this graph just because these are really small numbers, and this is what I got. That little sliver is your solution set where the green is. That's where the overlap happens, and any solutions set will be, any solutions will be points in that green area. Okay. Other than that, guys, that's everything. We do have homework if you're watching this before you turn in your homework for this module, and we do post the completed keys for the work problems and the homework. Good luck.